Okay, so let's move on to part B, a triangle of sides of length 3, 5 and 7 and find the size of the largest angle. So that means we are missing an angle. So again, draw a quick sketch of this triangle. So I have 3, 5 and 7. So let's make this 3. That one looks a little bit longer, that's 5, and this looks like the longest side, which is 7. And it's asking to find the largest angle. Well, generally, the longest side, the biggest angle will be opposite it. So we can call that x, say. So that there is going to be the largest angle. So what have we actually got here? We've got a side of 3, a side of 5, and a side of 7. We have 3 known sides and a missing angle. So for that, we've got to use the cosine rule. So our cosine rule is a squared equals b squared plus c squared minus 2bc cosine of a. Now what do we put in for a? Do we put in the 3, the 5, or the 7? Well, again, what are we looking for? We're looking for x. We're looking for the angle x. So when we do this calculation, it's going to be the cos of x. So if this is a, and this is the side a, that means up here, this has to be 7 squared. They have to be linked, the side and the angle opposite each other. And then b and c doesn't matter. So 7 squared is equal to 3 squared plus 5 squared minus 2 times 3 times 5 is equal to the cos of x. So now we've got to tidy this up. So 7 squared is equal to 49 is equal to 9 plus 25. And then we've got minus 2 times 3 times 5, which is minus 30 cos x. Something to bear in mind, this minus 30 belongs to the cos. So this will make a difference when you start moving numbers around. So on the left hand side, 49 minus 9 plus 25 is equal to minus 30 cos of x. So let's work this out. I just realized I made a small mistake here. That shouldn't be plus 25, that should be minus 25, of course. So 49 minus 9 is 40, and 40 minus 25 then is 15. So 15 is equal to minus 30 cos of x. So that means minus 15, bring the minus across, gives you 30 cos x. And again, we want cos x on its own, so it's going to be minus 15 over 30. It's going to be equal to cos of x. And minus 15 over 30 is minus 1/2. And that's the answer, don't worry about that for a moment. So we've got minus 1/2 is equal to the cosine of x. So how do we get x on its own? Bring the cosine over, and it becomes inverse cosine of minus 1/2, or minus 0.5 equals x. You end up with x then is equal to 120 degrees. So that finishes that one. The next one, 10a, is a construction. So we're just going to skip past that and measuring the sides. Again, same thing with part B, and we'll just move down here to 2016. Okay, so this is part C there in 2016. So it says use the theorem of Pythagoras to find the value of x. Okay, so Pythagoras' theorem, h squared is equal to a squared plus b squared. So we're going to square our hypotenuse. Our hypotenuse is opposite the right angle, so that's this side. So it's going to be x plus 1 b squared equals a squared, which is x, that's our a side, and our b side is the 5, so plus 5 squared. Square this out, gives you x squared plus 2x plus 1. If you don't know how to do that, you just work it out on the side of the page, equals x squared plus 25. Again, I'm going to get the letters to the left and the numbers to the right here, so we've got x squared minus x squared plus 2x equals 25 minus 1 when you bring everything across. The x squared minus x squared, they're gone. So that leaves you with 2x equals 24. And that gives you a nice simple x equals 12 at the end. Moving on to the next part. So John wants to draw a diagram of his farm. And he uses axes and coordinates. Okay, so we're not interested. This is a coordinate geometry question. Probably is a small little bit of trigonometry Further down, yeah. So use trigonometric methods to find BQA. So I'll let you guys work on that one while we skip on to the next full question. Question 5. Diagram shows triangle BCD and ABD with some measurements given, and it wants us to find BC. So let's have a look. BC is what we want to find. So we need to find this one here. The first thing I would do here is I would fill in any angles that I need to. So we've got 110, we've got 42. That's going to give us a total of 152, which means this angle in here is going to give us 28 degrees. And we've also got an angle in here that we could probably fill in. We've got 63 and 42 gives you 105. 105 from 180 gives you 75 as well. So I might use those in a second. So what have we got? Well, we can look at 28 and we can look at 42 and 110, and we need to find this side x. If we're finding a missing side, we might be using the sine rule. Let's see if we have everything that we need for the sine rule. So for the sine rule, we need the side we're trying to find and the angle opposite it. So in this particular example, x is the side we're trying to find, and actually 42 is the angle that's opposite that side. It's a little bit difficult to see, but we do have it. We also have 110 degrees, and we have the side opposite it, which is 16 meters. So we have everything that we need to work out our sine rule. So BC, or x shall we call it, over the sine of the angle that's opposite it, which is 42 degrees, is going to be equal to 16, that's the other side we know, all over the sine of 110 degrees. So that's going to leave us with x equals 16 over sine of 110. And you bring the sine 42 over and multiply. We're multiplying both sides by sine 42. And so x then is going to be equal to 11.393. So correct 2 decimal places then, x, which is BC, is going to be equal to 11.39 meters. Next, find the area of the triangle BCD. So in here, so we're finding the area of this triangle. So again, area of a triangle in trigonometry is 1/2 AB sine C. So we have plenty of angles and plenty of sides. So we've got 16 meters there. We figured out that this was 11.39 meters. And then we also knew this one here. We had that angle as well. This in here was 28. What's important when you're finding the area of the triangle is that you have to have the angle and the two sides that are surrounding it. So in this particular one, what I would use is I would use 16, I would use 11.39, and I would use my angle of 28. So we're going to go with 1/2 AB, so it's 1/2 16 multiplied by 11.39, and multiply that by the sine of C, which is 28 degrees. And when you put all that into the calculator, you're going to end up with, I have an answer written here in the inside calculator, we're going to end up with 42.778. You're asked to round it up, so that gives you 42.78 meters squared to 2 decimal places. Now it's asking you to find AB. So AB is the next one. So this side here is the side we're looking for. Let's just remove some of that. So in this particular example, let's have a look at what we've got. We have a side X. We have an angle that is opposite it, which is 75 degrees. And we have 10 and we have 16. And we don't have any other angles. So we don't have this one here and we don't have this one here. And because we don't have those, that means we can't use the sine rule. So if you ever have an angle with two sides on either side of the angle, so the 10 and the 16, and one angle that's opposite it, it means we're going to use the cosine rule. So again, let's go down here and have a go at the cosine rule. I can't see the page here, so it's going to be 75, 10, and 16 and x. 75, 10, 16, and x. 75, 10, 16, and x. So using the cosine rule, again, a squared is equal to b squared plus c squared minus 2bc and the cos of a. And we'll just make sure that the angle and the side opposite are the same. So we've got a squared, so that's x squared equals, and I'm putting in x there because we're going to have the cos of 75 because that's our angle. It's going to be 10 squared plus 16 squared minus 2 times 10 by 16. And all of this can be fired into the calculator and you end up getting out 273.178. So x then is equal to the square root of that, which is going to give us 16.528, then round it to 2 decimal places, 16.53 meters. So that finishes that one.